when you finally understand what Zero Trust is about. So Zero Trust is actually getting bloated. A lot of people are talking about Zero Trust and pretending they are implementing Zero Trust, but I can tell you it's often not true. So let's take a look at the real key pillars of Zero Trust. The first one is device enforcement. Device enforcement means that we're going to be able to assess the state of the device. Whether it's a laptop, mobile device, server, doesn't matter. We'll be able to find out and assign a strong identity to that device and be able to know if it's a personal device or a device managed by the organization. We're then able to see the patching state of the device, whether the device is properly updated, and also whether or not it's running an endpoint protection solution to see if it's passing the requirements. The second pillar is about the identity of the user, whether it's a person entity or non-person entity, meaning a person or a computer. We're able to use certificate for non-person entity, but also multi-factor authentication for users. The third pillar is about data centricity. That means that data will be labeled down to the cell level, and the user will be matched with labels to be able to define who gets access to what data. All of this is using the concept created by the Cloud Security Alliance called software-defined perimeter, not to be confused with software-defined networking. SDP is able to assess the device state. We call that comply to connect in DoD. And then we're able to map that to the user identity and compound the risk. And based on the compounded risk, you're whitelisted access to a dedicated, what we call segment of one. A segment of one is effectively a customized network on demand based on the device you're using and the user identity, so you cannot laterally move to see resources that are not accessible to you. Of course, the concept of SDP is based on mutual TLS tunneling with granular microsegmentation, so you only get to see what you're supposed to have access to. By adding a service mesh on top of that, you're able to do that whitelisting all the way down to the container level, making it very granular. The service mesh is able to enforce the east-west traffic as well, meaning container A talking to B has to be whitelisted. What's very important when it comes to Zero Trust is that the control plane, the brain of the system, has to be hosted inside of your enclave, whether it's on the cloud or on-premise. This should not be hosted as a platform, as a service. This is way too risky. You're giving the keys to your kingdom to a third party. As you can imagine, those are very heavily targeted by malicious actors. That's why it's so important that when you pick a Zero Trust stack, you're able to host the entire stack, including the control plane, on the cloud, on your services, ideally containerized, so you can host this on Kubernetes and be able to have all the baked-in security of DevSecOps. And if you missed the video on why you should use Kubernetes, even if you think it's overkill, check the video here as well. So now if you do a deep dive on the concept of software-defined perimeter, you're going to be able to see that the SDP grant access based on identity by looking at different things. First, we're going to look at the people with user-centric authentication, the device being used, the operating system, the agents running on that device, the different multi-factor authentication options. Then on top of that, you're going to be able to add the environment considerations. You're going to look at location, network being used, the time of the day, and the threat levels. More importantly, that access adjusts automatically based on that changing context. The beauty is that the user only gets to see what they're allowed and authorized to have access to. Unlike a VPN where they can laterally move across the network, with SDP and that dedicated segment of one, they only have access to resources that are whitelisted to them based on that risk factor. Of course, all this is built to be cloud native, massively scalable, and distributed. The device enforcement piece is often forgotten when people talk about Zero Trust. Of course, you cannot ignore the device if the device has a malware or is already infected. Obviously, that's going to be a problem. Malicious actor could then use the device to exfil data, use keyloggers, take screenshots of what you're doing as well. Now, let's take a look at what we call the Cloud Native Access Point, which was created by the Air Force and Space Force, the largest implementation of Zero Trust in the Department of Defense. As you can see here, you have two users. One user with a government device, laptop, and a personal mobile phone, and a second user with a government phone and a personal laptop. As you can see, based on the user identity and what they're supposed to have access to, they can effectively have access to different enclaves and different clouds, all through the same software-defined perimeter. So the same user on a different device does not get access to the same things with the same level of trust. As you can see here, a user with a personal device would have access to Office 365, but would not be able to access the Platform One stack with our GitLab secure repository. What's very important here is the beauty of the SDP controller and gateway enables you to access networks, whether it's on the cloud or on premise. That creates a single segment of one that is across all these physical locations, so you can now access resources regardless of where they're located. When you authenticate to the cloud native access point, you don't care where the resources that you're trying to access is hosted. You effectively connect to that SDP. The SDP is going to be able to enforce your device state, your user identity using multi-factor authentication, and then based on that component risk, is going to whitelist you access to resources. When you access those resources, you don't have to know where those resources are located. For you, it's a transparent, dedicated network that lets you access both on-premise and cloud-based capability all the way to the edge if you have to. Now, let's take a look at the data-centric policy engine. Data centricity is the foundation of Zero Trust. Zero Trust goes all the way from the user, the device, and the data. The data is labeled based on different conditions, delegated to the data owner. The data owner is able to define who gets access to what data and how. Each data is labeled and tagged, and those labels are then assigned to users either manually or automatically. That data-centric policy engine acts as a policy enforcement point, a PEP. The PEP is responsible to continuously authenticate and enforce the context of the decision-making to whitelist access to resources. This is effectively continuously assessing the risk to define whether or not a user should still have access to resources. As you can see here, the data-centric policy engine is able to connect to different resources by using APIs and different enablers to then query databases and application and resources all the way down to containers. The different resources are labeled and tagged, and using metadata, you can then enforce those access control requirements. Not only databases can be labeled and tagged, but data objects as well, all the way down to cells. So a field can be labeled and tagged so that users only get to see specific fields. That enables you to effectively host that data into a single data object or database, but only make it available to the users based on their need to know. There you have it. Zero Trust, 3 pillars. Device enforcement, to be able to know exactly the risk you're taking by using a specific device. The strong identities, both for people and systems. And data centricity, by labeling data down to the cell level, data objects, databases, applications, and so on. Then using the concept of software-defined perimeter, using the component risk of the user identity plus the device being used, you whitelist access to resources based on need to know with a granular control.